Hey everyone, welcome to our senior capstone project, Encampus. Here are the people who make up Encampus. My name is Gabriel Famudu, and I was one of the UI UX designers, along with a full stack engineer for the project. Through Encampus, we seek to solve a multitude of problems. How many times have you found yourself sitting there, stuck on a problem, knowing office hours ended hours ago? I know I have, I know everyone on our team has. And so with that, you're looking for answers on Chegg, you're looking for Canvas discussions, and maybe even creating some group chats trying to piece together answers from all these different mediums. This is the core reason why we created Encampus, to really streamline and create the single space where students can get help when they actually need it. Expanding on this further, Encampus is a classroom assistance platform that enables students to ask questions and get that help they need beyond regular hours. Through our method, students can share insights, answer each other's questions, and access AI-powered responses, which again creates a seamless space where academic success isn't limited by time or even location.
Hi, my name is Vincent Zhang, and my main responsibilities were combining the front end and back end, as well as translating designs to features by working within the Leptos framework to create proprietary components for navigation and state management. A major element of our process was the contextual design cycle, which identified three main goals for the application. First, as a student, I want to receive academic help by asking questions and receiving answers in a Q&A style forum. Second, as an instructor, I want to increase student success through moderation by promoting good answers and removing bad ones. And third, as an administrator, I want to address technical or operational issues by managing user permissions or course enrollments.
Hi, I'm Matthew, and my role on the project was that I handled most of the database development and development that interacted with the database. I also created a lot of components in the application that I built from the ground up, as far as the model and the controllers, and built the view following the style that was developed by other members of our team. So I did a lot of everything, but mostly back end and controller work. So here I'm signed in as myself. We can see my name in the corner up here, and here's the list of classes that I am entered in. I can see the title of each one, and then I can enter in and see the contents. We can also navigate between courses here on the side. Similarly, we can click this icon here to navigate back to, as a shortcut to navigate back to your class page and select a different class. So here I am in one of my classes. We have some neat features with adding posts. So here, just do our general title. So here we have an Encampus assistant that gives a immediate AI-generated response using the contents of your post, as well as some of the some additional features of the class to give context to our AI model that we're using. We can also get this message specifically be private to our instructor, so that not everyone in the whole class can see that, and that will be noted down below. We can also post anonymously so that our name doesn't show up with the post, so that when others say it wasn't private, or even if it was, the professors just at a glance won't see that, professors or the other students won't see that this post is from me specifically. So let's go ahead and check all three. So we get an immediate response. We'll have a little, this will be specifically to instructors, and we'll have a little icon down below to note that, so we can be sure of that. And this will be anonymous, so our name will show up as anonymous instead of our name. So we'll go ahead and post that. Then it will populate, and here we can see that it's currently unresolved because no professors have looked at it yet. But here's the little private icon to show that this is private. Not everyone in the class can see it. And then if we click into it, we have posted by anonymous author, so no one can see that it was me that posted this. And then here's the auto-generated response. Probably isn't too helpful with this specific question, but there are plenty of questions where this would be very applicable.
My name is Wentao. I was a full-stack developer responsible for creating front-end and back-end elements and connecting them. From there, instructors and TAs can create new announcements for the class, as well as endorse posts that they find useful. Then, of course, respond to a post and mark the post as resolved. Encampus also leverages plotting within Rust to create real-time visualizations of course statistics, such as current resolved versus unresolved posts.
So this is our admin homepage. Here admins have access to view all of the users and classes that we have in the system, as well as modify their information. Here we can see my information. Here is my information, as well as the ability to set my password if I needed to reset my password. Here we can also modify what classes I'm enrolled in as a student and as well as a TA. We can delete my account if necessary or save changes here. We can also do the same with courses. If we click here, we can see the course information for this course and modify that, as well as delete the class and save changes. We can also create new users and classes. By clicking here, we can see we can fill in this information to submit a new user. And then for classes, we have the same. We fill out the information here. Here's a drop down for professors or instructors. As well, we can step into classes and see what's inside. As an admin, we can jump into classes and just see what's in every class, particularly.
Hi, my name is Jack Shun. I've been the tech lead on Encampus, and so I'm going to walk you through both the tech stack that we use and the architecture layout. Starting with the tech stack, we're using what we're calling the PAL stack, which is a non-standard tech stack made up of Postgres as our relational database, Axum as our HTTP server, and Leptos as our full-stack web framework. You might notice that both Axum and Leptos are written in the Rust programming language. This is common in our project as we tried to write as much as possible in Rust. Moving over to the architecture diagram, you can see that this is made up of the client, which is where everything starts, using the web browser, which will make a request to our backend. Let's walk through how a request might happen. So the client starts off, goes to their web browser, and goes to encampus.dev. This makes a request to our HTTP server for a website. The request is forwarded to our web framework, which knows how to build the website and works very closely with our database. It'll make a SQL request and request data that it needs to populate the information on the website. It then builds a server-side rendered version of the HTML, which is then sent up to the browser, as well as any static resources that might also be needed for the website, such as CSS and our WebAssembly package. Going up to the website, you notice that the view of our website, how it looks, is made up of the HTML and the CSS, and then all the interactivity is in that WebAssembly package where there's actually a compiled version of Leptos running in the browser. Leptos is going to handle all the interactivity, so if someone clicks on a button or something, that user interaction is sent to Leptos. Leptos knows how to handle it, and it will update the view accordingly to make the website interactive. If Leptos is missing any information it needs, we use a process called remote procedure calls, which allows Leptos to go through a serialization process over the internet, make requests to our database and our handlers, and then take that information back, process it up here, and then update the view as normal.
Over the course of 16 weeks, we remain fully committed to agile development, holding weekly sprint planning sessions every Monday, with daily stand-ups to ensure continuous progress and timely responses to blockers or other issues. During this development period, we successfully closed over 230 tickets, submitted 150 merge requests, and made 810 commits. Our efforts resulted in the addition of over 5,000 lines of code. Through this process, we enforced our ability to collaborate effectively and adapt swiftly to changes, embodying the core values of agile development. The most important blocker we faced during this project was the challenge of balancing work, school, and our capstone responsibilities. With everyone on the team working at least part-time and half of us working full-time, we had to manage our workloads between coding, exams, and professional deadlines. This was further complicated by our choice to use a framework that was not only unfamiliar to us, but also still new and maturing in its development. Despite these challenges, we remain committed to our development goals, demonstrating resilience in a fitting example of the skills we developed, not just as software engineers, but also professionals during our time at the University of Utah.